Have you ever wondered how an AI actually learns to do anything? Well, it pretty much all comes down to three core methods. We're going to unpack them right now, and by the end of this, you'll get the engine behind almost every single AI you interact with.
So here they are, the big three: supervised, unsupervised, and reinforcement learning. These are the foundational pillars of pretty much the entire field of machine learning.
All right, let's kick things off with supervised learning. This one is by far the most common type you're going to run into. And the core idea here is actually really simple. The machine learns from data that already has all the right answers baked in.
Okay, so think of it like this. The model is a student, and the labeled data, well, that's its teacher. The teacher gives it a huge set of questions and the correct answers. The student's job is just to study them over and over until it starts to figure out the patterns for itself. The real trick, of course, is getting your hands on millions of perfectly labeled examples for it to learn from in the first place.
You know, this flashcard analogy is just perfect. The algorithm sees an input, say an email, and then it's shown the correct label, like spam. After going through this process with thousands, maybe millions of examples, it starts to recognize the patterns of spam all on its own. Supervised learning basically tackles two kinds of problems. First, you've got regression. That's all about predicting a number on a spectrum, like using past data to guess the future price of a house. Then you've got classification, which is more about sorting things into boxes, like teaching an algorithm to decide if an email is spam or not spam. So this system works great when you have all the answers ahead of time. But what if you don't? What if you just have a giant, messy pile of data with no labels, no correct answers to guide the way? And that question leads us perfectly into our second category, unsupervised learning. This is where the machine has to, well, fly solo. It's all about finding hidden structures in data without any guidance at all. So if supervised learning had a teacher, unsupervised learning has a detective. Its whole job is to sift through tons of raw, unlabeled data and just start looking for clues, connections, and patterns all by itself. The Lego analogy is honestly the best way to think about this. You don't have instructions, but your gut tells you to start grouping bricks by color, then by shape. An algorithm does the exact same thing with data, like for instance automatically grouping customers with similar buying habits, which can reveal market segments you never even knew existed. Now, this is usually done in two main ways. Clustering is that automatic grouping process we just talked about, like sorting the Legos. Dimensionality reduction is a bit fancier. It's about taking a massive, complicated dataset and boiling it down to find the most important, meaningful bits of information. Both of these are absolutely crucial for things like market research or spotting fraud. And that brings us to our third, and maybe the most dynamic type, reinforcement learning. See, this isn't about learning from a static pile of data at all. This is all about learning by doing, by interacting with an environment and learning from what works and what doesn't. The key players here are an agent, that's our learner, an environment that it can operate in, and a system of rewards and penalties. The agent's entire goal, its whole purpose, is to figure out which actions will rack up the most rewards over time. And that can take a whole lot of trial and error. You really can't beat the dog training analogy here. Every time the agent, in this case the dog, does the right thing, it gets a reward. Through simple trial and error, it eventually figures out a strategy to get as many of those rewards as possible. And this whole process is just one continuous loop, as you can see here. The agent tries something, gets feedback, either a reward or a penalty, it learns from that feedback, and then it tweaks its strategy for the next try. This is exactly how an AI learns to master a game like chess, or how a self-driving car gets better and better at navigating a tricky intersection. Okay, so we've got three really powerful but really different ways of learning. Let's put them all side by side to really nail down how they compare. This table really breaks it all down. If you just look at that first row, data type, you see the core difference right there. Supervised needs labeled data. Unsupervised works with unlabeled stuff. And reinforcement, well, it learns from live interaction. And that directly changes its goal, from predicting an outcome to discovering hidden patterns to learning the best possible move. The examples down at the bottom, spam detection, customer segmentation, a game-playing AI, they just show these different goals in action. So, if you're going to boil it all down to the simplest possible takeaway, it's this. Supervised learning learns from examples. Unsupervised learning discovers patterns, and reinforcement learning learns from experience. Each one of these is already changing our world in massive ways. But the really big question for the future is this:
Which of these approaches do you think will ultimately have the biggest impact on us? Will it be learning from what we already know, discovering patterns we've never even seen before, or learning through pure, unadulterated trial and error?